I'm back again with another request. Several of you indicated having some issues with number 25 from the textbook assignment. So we're taking a look at page 163, number 25. Once again, I'm not going to work through to a final answer, but hopefully I can give you something here that you can use to help you get there. I'll get you about as far as I can without actually filling in the numbers. So here we go. The situation we have here is that a 285 kilogram load is being lifted up. It's actually accelerating upward at 0.160 times the acceleration of gravity. So that gives us this acceleration, and it's moving upwards through a vertical displacement of 22 meters. And this is probably one of the things that you guys love so much about this one is it's broken down into 5 parts. However, that's actually a good thing because it's kind of breaking it down step by step. First thing it wants to know is tension. All right. Well, notice I drew a free body diagram. Guess what's coming? That's right. That we got the FBD. The next thing that's coming is the force summation, because this is just an N2L problem, Newton's second law. The net force acting on that object is going to cause that mass, whatever mass it has, to accelerate. All right. What's causing that net force? If I look at my free body diagram, that net force is being caused by a combination of the tension force pulling upward, which is greater than the weight pulling down on the object. In this case, we're being asked to find the tension. So now, essentially, for part A, all I need to do is just rearrange this and solve for T. All right? So tension ends up being the mass times the acceleration, which we were given, minus that. I'm sorry, plus. So I gotta get that over the other side. All right. Now, just straight plug and chug. So there's part A. Part B. In part B, now we're asked to find the net work done on the load. All right. Well, if I want to find the net work done on the load, I need to know the net force that was applied to the load. Well, that shouldn't be a problem once I know the tension, or actually, that's not a problem at all, because remember, the net force is what causes that mass to accelerate. Well, in this case, I know the mass of the load, and I know the acceleration it was given to me in my givens. So I know that net force. Now, to figure out the net amount of work, I just take that, I go to my work equation now. In this case, the net force times that displacement, the vertical displacement of 22 meters. And now one thing to remember here is that since, I don't want to forget that element there, because remember, that angle refers to the angle between these two vectors. Well, in this case, since it's accelerating upwards, the net force is acting upwards. It also is moving upwards, it's accelerating upwards, so that's also the direction of displacement. Since that's the case, the angle theta is going to be equal to 0 degrees, which means that this comes out to 1. And so to find the net amount of work in this case, this is what I would do. All right, flying on to part C. Part C, we're asked to find the work only done by the cable. All right? In other words, the tension of that cable. Well, if I want to find the work done by the cable, I just need to know the force of that cable, the distance it's moving, and the angle between that force and that displacement. Well, in this case, again, the tension force is pulling up. The distance or displacement, I should say, is moving up. So they're in the same direction. Once again, that angle is equal to 0 degrees. So that brings this term to 1. So you just have that. Part D. In part D, we're asked to find the amount of work done by gravity. Well, if I want to know the amount of work done by gravity, I need to know the force of gravity. Work done by gravity is going to be equal to, now the force that we plug in is the force of gravity times the distance times the cosine of the angle. Now in this case, gravity, mg, is acting downward, but that object, that mass, is moving upward. They're in the opposite direction. So now my angle is 180 degrees. Because remember, that's the angle between the force and the displacement. So when I go back over here, I'm going to substitute in for the force of gravity times the distance. And in this case, since it is the cosine of 180 degrees, I guess I better go ahead and write that in there. Now the work done by gravity is actually going to be a negative number. Finally, last but not least, part E. We are asked to find the final speed of the load. Notice I'm just going to write down my givens and my unknowns as I'm talking here. We're asked to find the final speed of that load, assuming it had an initial velocity of 0. Remembering that way up here, we were told what acceleration it has. Remember, it has an acceleration of 1.57 meters per second squared. And we also know the displacement that it went through, because it was moving through a displacement of 22.0 meters. Now there are two different ways we could do this. I could take a look at this list of givens and unknowns, and I can compare it to that dreaded list of kinematic expressions. And I can find one that ties together all four of those and solve for the final speed. That's one option. Or another option is I can remember the work kinetic energy theorem, the work energy theorem, which states that the amount of work done on that load to accelerate it is equal to the change in kinetic energy brought on by that acceleration. So the work is going to be equal to, and anytime we have a change in something, it's the final of that, the final value minus the initial value. Well, in this case, the initial value, we are told that the initial velocity or the initial speed is 0. So that value drops out. So now the work done to that object results in the final velocity, or the kinetic energy contained in the final velocity of that object. All right, and so now it's just a matter of rearranging and solving for the variable. All right, so hope that helps. Again, stop, pause, rewind, do whatever you need to do to figure out. And as always, if you have questions, you can reach me at Mr. Mason BPS, and also pay attention, because I'm dropping hints and knowledge every day. All right, hope this helps, and get in touch if you got a question.